Okay, let us continue the third part of today's class. Okay, now we are finding this the increment of this set. Okay, so when n is equal to 3, minus 1 to the power of n plus 1 over n is equal to minus 1 to the power of 3 plus 1 over 3, which equals to minus 1 plus 1 over 3. Oh, sorry, 1 over 3. Okay. So it is equal to, okay, minus 3 over 3 plus, okay, plus 1 over 3, which is equal to minus, okay, 2 over 3. Okay, like this. Okay, so next, when n is equal to 4, okay, the minus 1 to the power of n plus 1 over n is equal to minus 1 to the power of 4 plus 1 over 4. Okay, and then, okay, which is equal to 1 plus, okay, plus 1 over 4. Okay, and which is equal to okay, 5 over 4. Okay, so this should be minus sign, and this should be minus sign. Okay. Okay, so let's go on and on. Okay. Then what is the answer? Okay, we can use the MATLAB to help us to find the answer. Okay. Okay, so please wait a second, wait a moment. So we need some time to open the MATLAB. Okay. Okay, so let us open the new script and write a program. Okay. So y is equal to minus 1 to the power of n plus 1 over n. Okay, I think I need to enlarge the font size. Okay, please wait for me. Okay, publish, republish, editor, apps, plus home. Okay, preferences. Okay, and the fonts. Okay, let me change it to fonts. Change the font size to 18. Okay, good. And okay, let n be 1 to 100, and we can plot. Okay, plot n and y. Okay, let me save it first. Okay, the W and wireless communications and machine learning, computer progress. Okay, I call it Infima. Oh, sorry, Infima. Okay, change folder. Oh, sorry, I make a mistake. Okay, this should be point. Oh, sorry, point. And this should be point. Okay, so we can see that the infima, okay, is equal to -1 here. Okay, because this will this one decrease to -1, and this one will decrease to 1. Okay, but we are finding the infima, which is the greatest lower bound of the set. So the answer should be -1. Okay. Okay, good. So let us go back to the handout. Okay, inf qy given x of y given x, iq of y semicolon x subject to dq is smaller than or equal to d star. Okay, here qy given x of y given x, sometimes called a test channel, is the conditional probability density function PDF of the communication channel output. Okay, that is the compressed signal y for a given input. Okay, original signal x, and IQ of yx, that is this term, is the mutual information between y and x, which is defined as, okay, I of yx, okay, which is equal to h of y minus h of y given x, where h of y and h of y given x are the entropy of the output signal y and the conditional entropy of the output signal given the input signal respectively. Okay, h of y is equal to minus, okay, integration from the negative infinity to infinity, and py of y, okay, where py of y is the probability density function of capital Y. Okay, you can see, you can treat capital Y as a random variable, and capital X is also a random variable. Okay, times log 2 of py of y dy, and h of y given x is equal to minus integration from negative infinity to infinity, and integration again from negative infinity to infinity, qy of x of qy given x of y given x times px of x. Okay, where px of x is the probability density function of the random variable x, and the log 2 qy given x of y given x dx dy. Okay, the problem can also be formulated as a distortion rate function, where we find the infimum over achievable distortions for given rate constraint the relevant expression is, okay, infimum of over all possible qy given x of y given x. Okay, do you remember what is qy given x? Okay, sorry. Let me close my. Okay, nothing. That is the assistant of my cell phone. Okay, what is qy given x of y given x? Okay, sometimes called a test channel, is the conditional probability density function PDF of y given x. Okay. So, and the expectation of dq of xy subject to iq of yx, which is smaller than or equal to r. Okay, the two formulations lead to functions which are inverses of each other. Okay, because first one, okay, this is the rate distortion function, and this one is the distortion rate function. So the function, these two functions are inverse functions of each other. Okay, the mutual information can be understood as a measure for prior uncertainty the receiver has about the sender's signal. Okay, that is h of y, okay, the entropy of the y, okay, signal of the output signal y. Okay, where entropy is the uncertainty, okay, means uncertainty or randomness of a random variable. Okay, diminished by the uncertainty that is left after receiving information about the sender's signal, that is h of y given x. Okay, that is after you receive the information of sender's signal that is given x. Okay, the uncertainty of y. Okay, of course, the decrease in uncertainty is due to the communicated amount of information, which is I of yx. Okay, I of yx is the mutual information between y and x. Okay. As an example, in case there is no communication at all, then h of y given x is equal to h of y, and I of yx is equal to 0. Okay. Because no communication means that y is equal to 0 and x is equal to 0. And the entropy of them, of y given x, is also equal to h of y. Okay, because we do not have the transmitted signal x, because no communication. So the sender do not send signal x. Okay, so we do not know x. So h of y given x is equal to h of y, and I of yx is equal to 0. That is the mutual information between y and x is equal to 0. Okay, alternatively, if the communication channel is perfect and the received signal y is identical to the signal x at the sender, then h of y given x is equal to 0. Okay, because given x we totally know y, because y is equal to x. So given x, the conditional entropy of y, or the conditional uncertainty or randomness of y is equal to 0. Okay. And I of yx, that is the mutual information between y and x, is equal to h of x, that is the entropy of x, and is equal to h of y, the entropy of y. Okay, in the definition of the rate distortion function dq and d star, okay, let us go back to see where is the dq and d star. Okay. Okay, in equation 3, dq is here and d star is here. Okay. And in equation 7, okay, dq is here. Okay. So dq and d star are the distortion between x and y for a given q of y given x of y given x. Okay, that is the conditional PDF of y given x. And the prescribed maximum distortion respectively. Okay, when we use the mean squared error as distortion measure, we have for amplitude continuous signals. Okay, dq is equal to the integration from negative infinity to infinity, and integration again from negative infinity to infinity, and pxy of xy. Okay, this is the joint PDF of x and y, and times x minus y square of dx dy, okay, which is equal to the integration from minus or negative infinity to infinity, and the integration again, okay, also from negative infinity to infinity, qy given x of y given x times px given x times x minus y square dx dy. Okay, so why does this equality hold? Okay, because the joint PDF of xy is equal to the conditional PDF of y given x times the marginal PDF of x. Okay, you should have learned this relationship when you were taking the course probability, okay, in the university. Okay, as the above equations show, calculating a rate distortion function requires the stochastic description of the input x in terms of the PDF px of x. Okay, that is here. Okay, and then aims at finding the conditional PDF q of y given x, qy given x of y given x, that minimize rate for a given distortion d star. Okay, that is, we need to find this conditional PDF. Okay, these definitions can be formulated measure theoretically to account for discrete and mixed random variables as well. Okay, what is measure theoretically? Okay, there is a theory named measure theory. Okay, I remember when I was reading, okay, working toward my PhD degree. my divisor asked me to take a course named Real Analysis. Okay, let me show you. Okay, Real Analysis. Okay, this course 1 and 2. Okay, and in Real Analysis 1, the first part is to introduce the measure theory. Okay, what is the measure theory? Okay, let us see. Search on the internet. Okay, measure theory. Okay, measure theory. Okay, measure theory is the study of measures. Okay, then what is the measures? What are measures? Okay. Okay, the term measure, measurable, etc. have very precise technical definitions, usually involving sigma algebras. Okay. What are sigma algebras? Okay, let us see. Okay, let X be a set. Then a sigma algebra F is a non-empty collection of subsets of X such that the following hold. First, X is in F. Second, if A is in F, then so is the complement of A. Okay. Third, if An is a sequence of elements of F, then the union of the Ans is in F. Okay. If S is any collection of subsets of X, then we can always find a sigma algebra containing S, namely the power set of X. Okay, what is the power set? Okay, given a set S, the power set of S, sometimes also called the power set, is the set of all subsets of S. The order of a power set of a set of order n is 2 to the power n, power of n. Power sets are larger than the sets associated with them. The power set of S is variously denoted 2 to the power of S or P of S. Okay, so let us go back to the sigma algebra. Okay, so the power set of X, by taking the intersection of all sigma algebras containing S, we obtain the smallest such sigma algebra. We call the smallest sigma algebra containing S the sigma algebra generated by S. Okay, let us go back to the measure page. Okay, that can make them appear difficult to understand. However, the technical nature of the definitions is extremely important, since it gives a firm footing to concepts that are the basis of much of analysis, including some of the slippery underpinnings of calculus. Okay, for example, every definition of an integral is based on a particular measure, the Riemann integral. Okay, I think that you have learned what is the Riemann integral in calculus. Okay, when you were a freshman in the university, it's based on Jordan measure. Okay, let us review what is the Riemann integral. Okay. Okay, it is okay. It is 25 minutes. See you next time. Goodbye.